is a first for hexagon metrology, where we've been able to design and build a product taking advantage of all of the hexagon metrology brands. For instance, in this arm, we use Leica and even TESA components to build this device.
Which are the TESA components, by the way?
TESA on the joint and Leica components for our encoders.
Gotcha.
All right.
Okay.
So this is our ROMER Absolute 6-axis arm.
Okay. And why is this called the Absolute?
Because of the encoder type. They're absolute encoders as compared to incremental encoders used before.
Okay. And what's the difference between the two?
An absolute encoder, when you power it up, it knows exactly where the device is at.
Okay.
All right. So let's start with a little hardware review, since this is a new product. On the end, we have our probe joint. This probe joint is a TESA product, as I mentioned, which is part of the Hexagon Advantage. But what we can do here is remove the probe, load this probe or any other probe back, and not have to calibrate. And that's a huge time savings, but also some error proofing out in the field.
And that's because the calibration data for the probe is stored somewhere?
It's not necessarily the calibration data. The calibration data is there,
okay,
but it's also because of the mechanical repeatability of the joint. It's less than 1 micron.
All right.
Next, we have a USB camera built into the arm, so we can take pictures of things that you might not can measure, or take a picture of your setup for documentation purposes.
Can you describe to me a little bit how you might use the camera, how an operator might use that?
Certainly. As I said, if you have a feature, you come across a flaw in the part, it's maybe a gouge or a burr, you can simply take a picture of that, save it off with a report for people downstream to be viewing.
And it'd be saved with the scan that you're doing, or is there just a separate kind of a separate thing?
It's saving off as a JPEG.
Okay, all right, gotcha.
Okay. Next thing is we do have infinite rotation on this arm. All right. With all the arms ever since the Infinite 1.0, we wanted to maintain the infinite rotation. This gives you the ability to move the arm around without having those end stops.
Okay. No unwinding.
No unwinding.
Okay.
So here we're absolute and infinite.
All right.
All right. With all arms built from ROMER, we're still using carbon fiber tube construction. The carbon fiber tube construction is a design of choice because we have lightweight material, very rigid material, and thermally stable.
All right.
Next, we'll see our spin grip. So this gives us an approved location to hold the arm and move it throughout its position without implementing any torque or force to the arm.
Okay, so this just allows you to hold it without any friction rolling through your hand and that sort of thing?
Exactly.
Okay.
In the tightest of applications, it gives you an increase of benefit of accuracy and repeatability.
All right.
Next item of interest on this particular arm is the elbow joint. What we've done here is with a single piece of material, we've machined in the 2 housings that hold the encoder